So the readiness monitors. We've got two types of monitors. We've got continuous and non-continuous. And they just what the word implies. The continuous monitors will generally run all the time, although they can be disabled. For instance, the misfire monitor can be disabled on a gravel road. Okay? Or the misfire monitor can be disabled if the tank is less than 15% of fill. Things like that. So there's some stuff out there where where a continuous monitor may not be running continuously, but for the most part they are. If you clear code with the scan tool or you disconnect the battery, then the monitors are going to go to not ready. So these are the continuous monitors, misfire fuel system, comprehensive component. Comprehensive component is the one that encompasses a ton of the codes. There's just a whole bunch of them in there. It's kind of a catch-all. Examples of non-continuous are catalyst monitor, heated catalyst monitor, and evaporative monitor. I think there is a vehicle that may have made it into production with a heated catalyst. Seems to me it was a European model, mid-90s, 95, maybe 96, something like that. I don't even know if it even hit the U.S. market. But outside of that, you're not going to see any heated catalyst monitors. They're all going to be unsupported because they don't have heated catalysts on vehicles. They couldn't make them work. A durability issue. And then the other non-continuous secondary air monitor, oxygen, heated oxygen, they're non-continuous, EGR, and AC. AC is the same thing. These regulations were written in the late 80s when they started on this. There was still CFC, chlorofluorocarbon refrigerants, R12. But by the time they were actually implemented for the 96 model year, there wasn't any of that refrigerant left. So you shouldn't see an AC system monitor. It seems to me there's a couple of mistakes out there manufacturers made, but you shouldn't see a supported AC monitor.
We always see them already set.
What's that?
On the list of readiness tests, the AC usually already says passed.
Well, yeah, it depends on the scan tool as to how they report it. This is an example. I think this is the ease. So what they show is either supported or unsupported, and either complete or not complete. So yeah, but scan tool manufacturers are kind of, they kind of run the gamut of what their wording is. So you want to be familiar with your scan tool, what that means. Does your monitor, is it supported or not, and is it ready or not? All right, so drive cycles or trips. In some cases, the vehicle has to be run under special conditions, and that's really prevalent with P0420, P0430, catalyst monitors. They're really picky about where they run. Evaporative systems, the same thing. They're pretty picky about the conditions that they're under. They may have some temperature constraints. Less so O2 sensor heaters. So you need to be familiar with that's in most of those a lot of them are in your service information. They'll tell you what it takes to run the monitor.
Is there any consistency as to the number of drive cycles from car to car, monitor to monitor? Is there any consistency that if you did X number of drive cycles, you would be confident that you got all of the monitors ready if they would get ready?
No.
Okay.
They've gotten better. He's asking if there's any consistency, meaning right here, a universal drive cycle. You're not participating, it's pretty good. So this is a universal drive cycle, right? If I drive this, then the monitor will set to ready. Except it's universal, it fits nothing. We haven't had very good luck with it in the lab, trying to get this thing to work. The older vehicles especially, 96, 97, 98, they had all kinds of crazy criteria. Mitsubishis were bad for it, Volvos were bad for it, Mercedes-Benz. You had to do some really weird stuff to get the drive cycle set to ready. But ARB's tightened up on that. So by about 2004 or so, monitors should be setting relatively pretty quickly. If you got a monitor that's not setting to ready, especially in these newer vehicles, not the 96 as much, if you got one that's not setting in 2003, 2004 model year, somewhere in there or newer, you probably got a problem with the car. There's an issue with what's called a deadband. So when they're trying to figure out, catalysts are a good example. So the catalyst will run a monitor, and they've got an example of the best failing, right, and the worst passing. And a lot of times those will overlap, meaning that this is the best failing, this is the worst passing. If it's in the middle, in here, it doesn't know. Or I guess, no, this would be the best passing, this would be the worst failing. Anyway, it's in the middle there. It could be bad, but maybe it's not bad. So it'll test it again. Well, it's still in the dead band. So it'll test it again, and again, and again. And we've seen monitors not set for months while they're sitting there trying to figure out if this, but this means the car has a problem with it. It just is having trouble determining what that problem is. The monitor may or may not be set to ready in that condition. Manufacturers do it both ways. But if you're having trouble setting a monitor, that may be one of the, could be one of the reasons.
So the reason I asked the question primarily is you get a guy, you get a motorist that fails, they bring it in, an OBD2 test, they bring it in, you repair the car, you de facto are clearing the codes, right?
You may, or you may not. You're asking, should you clear the codes? Well, in some cases, you may not. And that's going to be, anybody in here remember IATN or any of the bulletin boards? All right, so you see those debates go in there about what to do with these monitors. Some businesses are saying, no, I'm not going to clear the code. Remember, the code doesn't make it fail. So they'll go out, especially, let's say it's what's the throttle by water? Throttle by water. ACC, is that the throttle by wire system? All right, that's going to be a continuous monitor, okay? That's a circuit monitor. You've got a TPS. Let's make it a throttle position sensor. So you replace the throttle position sensor, all you got to do is turn the key on 3 times. You just set, it just saw no problem for 3 times. It's going to turn the check engine light out for you. So if it's one of those types of systems, you may just want to drive the vehicle, get the monitor to run 3 times for that DTC, and let the system turn the light out, and it'll pass. Then you haven't cleared the codes, or you haven't cleared the monitors. They're all still set to ready. Other cases, that's not really a good option, because you need to do a relearn, let's say, on a vehicle. So it's going to vary depending on what the problem is. So that's one of the things you're going to want to try to figure out is, do you want to set these monitors, do you want to clear codes or not?
And before you return the vehicle to the customer, if he's going back for a retest, it's going to be our responsibility really to make sure we get enough drive cycles to get
Right.
the monitors ready.
And I've noticed in some of the localities where they do OBD testing, some of the shops have bought these like, they're like a monitor, I don't know, monitor ready RS or something. They're relatively inexpensive. They may get a deposit form or not. Then they just plug them onto the OBD connector, and when it's ready, 3 lights come on, or a green light comes on, something like that.
And all the monitors are ready.
Yeah, and then they say, okay, the monitors are ready. When it's ready, bring it back to me. I'll take that, and we can go get the vehicle tested. So there's stuff out there you can do. Various businesses are doing different things, but you definitely want to be thinking about that, because it's not going to be good to send it back to the lane if the cat monitor is not set to ready. Well, it's going to get rejected.
That becomes if it were a predictable thing and you were confident that you had the car fixed, you could give it back to the customer and say, go drive like this and turn it off, drive like this, turn it off. Now it's ready, go do it. But if that's not a predictable thing, either we have to do it or we have to have some instrument that allows them to know it's ready.
Right.
Yeah, interesting.
Great. Yeah.
So the driver does not have a choice of whether it's going to get an OBD2 or the IM240 test.
Well,
no.
Correct. The driver's not going to be the one that decides whether, they can't go in and say, okay, I want an IM240 test. Or I want
On a lot of modern German cars especially, the second oxygen sensor is only measuring the efficiency of a very small, like schnitzel-sized pre-cap, whereas the big cat is behind that, and the car is very clean, but it's failing due to the efficiency of the little schnitzel-sized pre-cap.
Right, but the reason they do that is because catalyst degradation takes place from front to rear, from center out. So by the time the front part of it has degraded, the back half is still probably fine.
Right.
Right.
So
So
the
that's
car
why
would
they're-
still pass the IM-240 test, but
It
you're
may,
just throwing a
yeah,
cap.
remember the .07, so if it's a tier 2 bin 5, it's a 2008, that light's gotta come on at .1 something, of grams per mile and ops. Well, the lowest cut point we got is 1.2. So yeah, that can happen.
Okay, but they don't have a choice. They can conceivably have to
No.
replace a $1,500 cat that's still blowing very clean just because the small pre-cat is not working.
Correct, yeah. Right, and that cat's gonna continue to degrade, and what the rate that is, well, who knows? But eventually the cat's gonna be failing the IM-240 as well.
We see a lot of cat failures that the car is just fine, because the
Yeah, we
big
see
cat
it
is
too.
just fine.
Yeah, we see it too in the data. But the motors can't pick. Yeah, that'd be, if you allowed the motors to pick whatever test they wanted to be infinitesimally unworkable, because then it would be just a free-for-all. This car got this test this time and this time. So we are gonna allow some deviation from OBD or IM-240, but it's gonna be pretty limited. So this is another one, 2,650 seconds, that's about 44 minutes or so. This is a Ford drive trace. And then what they do is they tell you to go out there and drive it, and then let it sit overnight. The next morning, start it up, monitors should be ready. If they're not, try to do it again. So thankfully, in the 04 to 08 era, once you get past about 2001 or so for the model year, the monitors run fairly quickly. California tightened up on that. They've got a monitor performance ratio now, and the manufacturers are running these monitors a lot easier than this example. This is an older example, late 90s. All right, go through the communications modes, and then we'll see if there's any questions. We'll get you out of here. So I need to go through these because you need to understand what's going on in the lane. Now your scan tool does all of this. You may not know that it does it, but it does. So the first one in J1979 is the SAE standard that governs the car, how all this stuff comes across. So the first one's mode 1, and that's hex. That's what the $ sign means. So it's mode hex 01. And this mode, so when the car goes to the contract Enviro test and they plug on, the first thing it's going to do is going to do a mode 1 request. So it's going to go out there and says, I want this information. This is where the stuff that you see on your scan tool, much of the stuff that you see on your scan tool comes across on mode 1. The PIDs are in there. PPS, mass airflow, what have you. The mill command is in mode 1. Monitors are in mode 1. So a lot of the data that you request is in mode 1. Okay, so when you say I want to look at the PIDs, what you're really doing is you're doing a mode 1 request to the system. Now, there's certain things that are supposed to be in there. For instance, fuel rail pressure is listed in J1979. It has to be in there. That's one of the PIDs. It has to be in there. However, if it's not on the car, which most manufacturers don't monitor the fuel rail pressure, then they don't have to put it in there. Do they follow that? All right. Next, limitations on mode 1. Now some of you guys, and you're going to have to pay attention to this one, because some of you guys are dumping over into the manufacturer-specific stuff. You may have a manufacturer-specific scan tool. You might have a Tech 1, or you might have a PRV3 or something like that for the old Chryslers. You got to know, am I on the manufacturer side, or am I on the OBD generic side? Because you're going to get much different. You can get very different information depending on how you do that request. Some of the limitations on some of the, especially on the older stuff, the scan tool on the factory side had a much faster baud rate. So you may be in the habit of just going right over to the manufacturer side because it's so much faster. The data reporting, there's variations. You may get data on the manufacturer side that you can't get over on the generic side. But you just need to know with your scan tool, where am I at? All the contractor Enviro test is going to look at is mode 1. They're not going to go over on the enhanced side on any vehicles. Okay? So it's mode 1, that's where you get the information for why the vehicle failed. Mode 2 is your freeze frame data. The contractor will not be doing a mode 2 request. Okay? Mode 3 is DTCs. So when you ask for DTCs, what you're really doing is mode 3 request. And then the lane, the EnviroTest will be doing a mode 3 request. If we want to get those DPCs off of there. Mode 4 is where you clear the codes. So when you go into clear codes, what you're really doing is mode 4. Do a mode 4 request. EnviroTest is not only not going to do a mode 4 request, they're forbidden to do a mode 4 request for obvious reasons.
Yeah.
Don't want you clearing codes. I guess I haven't made this point yet. Some early model vehicles, especially 96, 97, 98, were a mess on readiness monitors. Subaru was an example. Every time you turn the key off, cleared the monitors. It was why they did that, but they did. We know about most of those, especially in the older ones. Now again, we're not going to be testing a ton of older ones, because we're only doing the old 4, but they're going to be testing some of them. In that case, we know about that with Subaru, so we're not going to apply that mode, the readiness criteria to Subarus, because we know it's a mess. So we're going to test the vehicle irrespective of the monitors. There's a bunch of them in there. There's Mitsubishis, there's Volvos, there's 6 model year vehicles that we know of in those years that the manufacturer really screwed up. Some of them, like the Chrysler, now that one we will be testing, that's 96, 97, because there's a recall on those. Chrysler had to recall those vehicles. So the ones we know about, we'll let those ones through without the readiness mode. But again, for us here in Colorado, probably not going to be a ton of those vehicles because we're not going back that far with OBD. Mode 5, 6, and 7, those are basically the values generated by the various monitors. Most of you guys are familiar with mode 6. That's where you go and look at your SIDS and TEDS to see what the tests are, see what kind of tests is performed, how close was it. Mode 4 was pretty good on some of the older vehicles like Ford. They've really stunk on some of the vehicles like GM in the early model year. So ARB did clean that up by CAN. So if you got a CAN vehicle, basically the 04 and newer, those mode 6 will probably be pretty good. So 5 and 6, a lot of pass-fail criteria there. So if you want to see how close it passed or failed, you can see that. Mode 7, earlier, some manufacturers put pending codes in mode 3. Some didn't. There was no rule or requirement on it. By the time CAN rolled around, by the time the 04s rolled around, it was required to be in mode 7. So now the pending codes are definitely going into mode 7. That's a requirement. Right now, let me back up. EnviroTest will not be doing a mode 5, 6 request. Okay, not going to be pulling that information over. They may do a mode 7 request at some point, perhaps next year, to look for pending codes. But at least at startup, they won't be.
Is a pending code criteria to spell it?
What's that?
Is it
No,
code?
pending, yeah. So codes are always irrespective of a fail. It will never pass or fail based on a code, like what number it is or anything like that. It's only the mill status. So pending are the same way. Even with no pending, even if there is a pending code, it will not fail unless the mill is on it. 08 is bidirectional control, essentially the purge, or canister vent solenoid. EnviroTest will not be doing a mode 8 request. And a mode 9, again, not an initial startup, but we're probably going to see this next year, but we'll be doing a mode 9 request because that's where things like the vehicle ID is, CVN, calibration verification number, vehicle data like the VIN. It will be reported in mode 09, but that wasn't mandated until 2005. Okay.
So that's a future topic, but would they be looking at that data for consistency?
We can. One of those things that we talked about, like I mentioned when you and I were talking about it, is that this is one of the things that it's going to be built into the software. Calibration verification number, as an example. That's essentially a checksum. I don't know if you guys are familiar with it or not, but it adds up all the line of code, okay, and it generates a number based on that. So if a tuner goes in and changes anything in there, anything at all, it's gonna change that CVN number. And then we'll be able to tell, and, potentially. Now, that's not gonna be turned on at startup, so.
We've actually seen some cars that had the ECU updated by the dealer, and instead of reporting as an 01, it now reports as an 03.
Yeah, there's a couple of those out there. They're pretty rare, but there's a couple of those oddball, because they actually changed the programming to an 03.
And that potentially,
Yeah, I don't think that would come up with it,
Okay.
but again, those are things that we're gonna be pulling that data across, and some of those things, for instance, a PID count, that might be a way. Vehicle comes out and it's, we count all the PIDs, let's say there's 27. Well, you see that vehicle at the next test cycle, now it's got 3. Problem. There's a lot of things like that that could be done to look for tampering. So, but at startup, none of that stuff will be.
and that's
looked
a
at.
future topic.
That's future stuff, right. And then finally, mode 0A, it's not mode 10, because it's a hex number, 0A is the permanent fault codes. Again, we talked about that. So that can only be erased by the processor, and it's basically to get around this problem you were bringing up, where somebody's, disconnecting the battery, 2 blocks away, and then bringing it in. If it's got a code, permanent fault code will also be stored starting in 2010, and then the only way that permanent fault code can go away is if the processor does a test, sees that it's not a problem, and it'll erase the permanent fault code. Again, future stuff, not being done today. And cans on all vehicles by 2008, it's used on some 2003s. And that cleaned up a lot of problems for you guys when they went to CAN.